Hello folks and welcome back. Today I want to talk to you a little bit about graphs. Now graphs are a way we can show computer data in a manner that humans will understand. Now this is 5 nodes and next to it is an adjacency matrix. That's the thing my little dot is on here, okay? And this is how the computer would see it. The computer sees ones and blanks everywhere. Humans, though, don't really understand this as well. We like to see nice, big, colourful drawings. So we are going to demonstrate how this would represent on the chart. So, firstly, there is a line from A to B and from B to A. So let's get a nice pen out and bingo, banga, bongo, there is a line right between them. Secondly, there is also a line from C to B and from B to C. So we'll do a line between B and C. Secondly, there is a line between C and D, or between D and C. So again, we just take our pen and we do a nice line between D and C. Finally, there is a line between D and E. These two nice little ones down here. One indicates there is a link, okay, in case you haven't worked that out yet. And D and E. And then finally, there is a link between E and A. So AE, AE. Okay, so let's put a nice little line in there. And that is a very, very, very simple graph. Okay, but they can get a bit more advanced than this. The next one to look at is a weighted graph, which is much more exciting. Now, weighted graphs have labels on their lines to indicate how long the distance is. So A and B are linked up again. So I'm going to take this and I'm going to put it in here. But you'll note, guys, there's a number next to them. So I'm going to try and write the number. This board isn't very good for this. 5 is now next to it. So now we know the distance between the two. Okay. Next, there's a line between C and B. So we'll go between C and B. And again, the number here is 7. Please note, guys, these numbers are nowhere near scale. This is what in computing we call an abstraction. Okay? Between C and D, there is also a line which has got 6 spaces on it. So, there we are. Our abstraction is now doing well. And there's also a line between D and E, and that is 3 spaces between them. And finally, there is a link between A and D, and this has 12 values in it. That's got 12 on it. So that is a weighted graph. Weighted graphs contain numbers to tell you how long or how big the connections are, but as an abstraction, they are not to scale. Okay? So that's a better way of doing it. That's a more interesting way of doing it. But there is one more, even cooler and more exciting way of doing it. And this is when we do a directed graph. Now, directed graphs, data can only go in one direction. So you don't have to go both ways. It can only go one way. So A links to B and C and D and E. And each has a weight, as we discussed last time. So A, and there's an arrow at the top. And there we go. And now there is a link between C and A. Sorry, between B and C, my mistake. A link is here, B and C, and D and C. So I can now put in another little red line here There we are. Now the one thing I didn't do here, guys, was put the weights in. Very silly of me. So let's do that now. C and A have got a 6 between them. A and D have got a 7. And A and E have got an 8. And between B and C, that's a 3. And this is a 4. So, guys, the arrows, and only going one direction, make it a directed graph. Okay, the numbers make it into a, there we are, a few numbers there. They make it a weighted graph, and the fact we have nodes with lines between them make it a graph in the first place. Okay, so that's all we have to learn about graphs. Just remember, they're a very cool way of doing abstractions. Okay, so thank you very much, and I will talk to you again soon.